So now we're getting into some more complex functions. In this case, the limit as x approaches 0 of x over the square root of x plus 4 minus 2. Now, first thing to do, this function here is really just a combination of a bunch of individual functions where we know that we can evaluate the limit by substituting, as long as 0 is in the domain of this function. So there are properties of limits, I could talk through them real quick, that say, first of all, the limit of a ratio of two functions, f of x over g of x, is equal to the limit of the top over limit of the bottom. So we would be allowed to break this into two separate limits in the numerator and the denominator. And then for the limit in the denominator, we could break that, so if there's subtraction, we can do limit of the first part minus limit of the second part. And then for our rational expression, that is one of your properties that said we're allowed, as long as this number again is in the domain, we can evaluate the limit by just plugging in. So just long story short, as long as x is in the domain, you can evaluate the limit by simply substituting in x equals 0. However, if we plug in x equals 0, the numerator is equal to 0. The denominator will be square root of 0 plus 4. So square root of 4, which is 2, minus 2. We get 0 in the bottom. So we get that old indeterminate form, which, again, this 0 over 0 form kind of tells you two things. Well, so I can't determine the limit if I leave it written this way. But here's the thing to think of when you see 0 over 0. I can probably do some kind of algebraic manipulation, so use some of the skills that you developed in algebra to rewrite this expression in a way where you can get it out of that 0 over 0 form, maybe, eventually using algebra. That's the hope, when you see 0 over 0. So the trick to these problems where you have a radical expression is to multiply the numerator and denominator by the conjugate of that radical expression. And I'll put that in writing. So what we're going to do now is multiply the numerator and the denominator by the conjugate of the radical expression. So in this case, the conjugate of the radical expression is the square root of x plus 4 plus 2. You just change the sign in the middle here to get the conjugate. So, hopefully I've left myself enough room here. We want to look at the limit as x approaches 0 of x over the square root of x plus 4 minus 2. Multiply numerator and denominator by that conjugate, the square root of x plus 4 plus 2. But so if I want to do that in the denominator, I have to do the exact same thing in the numerator. Otherwise, you're drastically changing this expression. Okay. So here's one place where students can tend to get off track. You should multiply this out where you're multiplying conjugates, because that's where something nice will happen. That's where the whole multiplying by conjugates thing actually is going to help you out. You should not distribute the x in the numerator. And the reason is we're hoping that eventually, I said before with this 0 over 0, we're hoping to eventually cancel some common factor that's making the numerator and the denominator both equal to 0 when we plug in this case, x equals 0. So we're hoping to cancel a common factor. Distributing x in the numerator is not going to help us in terms of canceling a common factor. So we want to leave this expression, or leave the numerator in the factored form. Where you're multiplying conjugates, though, you should multiply that out. So in this case, I'm going to do the old FOIL method. I'm going to get another color here. So we're going to FOIL in the denominator. First, outside, inside, last. It's just one way to think about multiplying out expressions like this. So the square root of x plus 4 times the square root of x plus 4. When you multiply a radical expression times itself, that means you're squaring the square root of x plus 4. And so that'll get rid of the radical. So that's just x plus 4. Now when we do outside, you have positive 2 times the square root of x plus 4. Inside, you have minus 2 times the square root of x plus 4. And then last, negative 2 times positive 2, so that's minus 4. Okay, so whenever you multiply conjugate expressions, the outside-inside part, when you FOIL, that's going to cancel itself out. So in this case, notice the positive 2 square root of x plus 4 and then minus 2 square root of x plus 4. And that always happens when you're multiplying conjugates. So you don't need to write the outside-inside parts of this multiplication. You don't have to write that out. I wanted to write it out this one time. It's right in the glare, so hopefully you can see it okay. But to help everybody see what's going on. But if you want to just do that in your head and just write x plus 4 minus 4, that would be fine. Okay, yeah, and speaking of this denominator now, right, so we've got x times the square root of x plus 4 plus 2. What's left of the denominator is x plus 4 minus 4. So actually the plus 4 minus 4, those cancel out as well in this case, and you're left with just x. And so this is what we were hoping to see, a common factor that we can cancel out. And notice that once you do that, once you cancel those x's, now 0 is in the domain of this expression. It's not going to make our denominator equal to 0 anymore. So that right there is why you should not distribute the x in the numerator. So in general, when you do this multiplying by the conjugate technique, multiply it out where you're multiplying conjugates, leave it factored if you're not multiplying conjugates. Okay, and so now we've got the limit as x approaches 0 of the square root of x plus 4 plus 2. And so that's equal to the square root of 0 plus 4 plus 2. And so that's 2 plus 2. Our answer is 4. And so this time 0 over 0 turned out to be 4. Like, just to reiterate the fact that 0 over 0 really is an indeterminate form, cannot determine the limit based on 0 over 0.